cosine of 2x, right? So I start by doing 1 over 2 times the square root of u, right, times du dx, because that's the chain rule. But I'll go ahead and write that d dx of what? And then what do I need to do? So here, like, when do you need to do the chain rule? Is whenever you're differentiating with respect to a variable which doesn't match the variable of the function you're looking at. Like, whenever you see that pattern mismatch, that means it's a chain rule you have to do. So here, I'm going to look at that as 1 over 2 times the square root of u d dx of 1 plus the cosine of w, where w equals to 2x, right? So that requires a chain rule. And the chain rule here, we got what? ddw of 1 plus cosine w times dw dx. What's the derivative of 1 plus cosine w? Negative sine w, right? So 1 over 2 times the square root of u minus the sine of w. What's dw dx? Just 2. So our differentiation's done. Now we can put back in the substitutions, put it back to x, you know? And what we're looking at here is minus 2 times the sine of 2x divided by 2 times the square root of 1 plus the cosine of 2x. So this one was a little bit harder because it did what? It had not one chain rule, but it had 2 chain rules, right? Because it was a chain inside a chain, so to speak. I mean, yeah, the multiple chains. You're like, well, that did not give me joy. Do something simpler. Fine. d dx of e to the x squared. So this is d dx of e to the u. All right? Which is what? E to the u times du dx, right? I mean, I can write another step here. Fine. d du chain rule. But the derivative of e to the u is e to the u. So we're looking at e to the u times d dx of x squared. Derivative of x squared was 2x. So we have 2x e to the x squared. There you go. Another example. d dx of e to the sine x. I'm going to write less this time. So it's an exponential. So we do the derivative of the exponential is just the exponential again. And then I have to multiply by the derivative of the inside function. That's the chain rule. Derivative of sine is cosine. So this one, we've got cosine of x e to the sine of x. Again, I didn't write down u explicitly. What was the u here? U was equal to sine x, right? Any questions? So the homework that you're working on, hopefully, it is wall-to-wall product rule, quotient rule, chain rule, all this stuff. I think it's mostly product and quotient, not as much chain, but sometimes we have to use all three, right? Oh, one thing I haven't hit on yet, I don't think in any example yet, and I should. Well, so I was supposed to talk about higher derivatives today, and we've talked about those a little bit before, but how do you calculate higher derivatives? Like, if this is f of x, remember, okay, so if f of x is equal to e to the x squared, right? Then we just calculated in example 7 that f prime of x was 2x e to the x squared, right? So what would f prime prime of x be? That is not how it works, though. So we have to think through it. We have d dx of f prime of x, which in this case is 2x e to the x squared. Now what you just said, Myron, that's part of the answer. There is a term like that. But we have to think through it. So we have a what? We have a product of functions. We have to do product rule. So this is, I'll write up here, d dx of 2x e to the x squared plus 2x d dx of x squared. Of course, we just worked out the derivative of x squared already, right? So we know what that works out to. We know that this piece works out to 2x e to the x squared by the chain rule. In fact, that was example 7, right? Yeah, we could simplify this, couldn't we? This is 2 plus 4x squared e to the x squared. You could factor it out of 2. That's true. I could have. I'll leave it like that, though. Now, so you're asking me before, should I simplify, shouldn't I simplify? What if I asked you to calculate the third derivative here? Which do you want to differentiate? Do you want to differentiate the simplified formula, or do you want to differentiate the unsimplified formula? Well, if you do this one, though, then you got to differentiate this, and then you got to differentiate that. And if you really do this, if you just don't simplify it at all, right? Check this out. You'd have, I'll chase that rabbit here. d dx of 2e to the x squared, right? Plus d dx of what? 2x times 2x times e to the x squared. That's a product of 3 things. There is a product rule for 3 things. I don't think I've stated this for you guys yet, but here it is. If I have like a, b, c prime, the product rule for 3 things goes like this. A prime bc plus a b prime c plus a b c prime. You can get this from applying the product rule 2 times. See, because ABC prime is AB times C prime, right? So that gives us AB prime C plus ABC prime by the product rule. And then by the product rule again, that's A prime B plus AB prime times C plus ABC prime, which then, of course, is A prime BC plus a b prime c plus a b c prime, which is the product rule for 3 things. So the product rule for 3 things you can get from applying the product rule for 2 things twice, just like that. But that is the product rule for 3 things. And you can tell me what the product rule for 4 things would be, right? If you have ABCD prime, it's a prime BCD plus a b prime CD plus a b c prime D plus a b c D prime. pattern continues. This is often a homework problem. I just don't think it appeared on your homework, but often it is. I'll assign that as a homework problem. So if you do go down this path and you're really so foolish as to not simplify this, then you got to do that. And you could, right? But do you want to? I don't want to. I don't want to. Let's not do it that way, right? A much better way is to differentiate what's in the box, right? So, hey, but there are other problems where you're going to need that triple product rule, right? I just artificially inserted it in this example. So this one, we have d dx of 2 plus 4x squared times e to the x squared. And so we have the derivative of the first one, which is what? What's the derivative of 2 plus 4x squared? It is 8x e to the x squared plus 2 plus 4x squared times the derivative of e to the x squared, which is 2x e to the x squared. And then you could simplify your answer if you wanted, right? Now, what did I just do in this last example? Well, every time before this in class, I have written out the product rule before I actually did the differentiations in the product rule. This time I did the differentiation in my head and I wrote down the product rule. Right? Eventually, once you're good at this, you don't have to write everything down. But as you're learning, of course, write more, because otherwise it's really hard for instructors to give you partial credit, right? All right, example 10. Suppose we're differentiating with respect to x. E to the x times the square root of x times the hyperbolic cosine of x squared. I'll do x cubed. We've been doing too much x squared here. So what's this going to be equal to? So we're going to use that triple product rule. So we do d dx, I'll write it out, d dx of e to the x times the square root of x cosh of x cubed, right? Plus e to the x times the derivative with respect to x of the square root of x times the hyperbolic cosine of x cubed plus e to the x root x times the derivative with respect to x of the hyperbolic cosine of x cubed. We got those three terms to deal with using that triple product rule that I just mentioned. And so we can do these differentiations, right? We have e to the x, square root of x, cosh of x cubed for the first term, plus e to the x over 2 times the square root of x, cosh of x cubed, and finally e to the x, square root of x, sinh of x cubed times 3x squared. Now, where did that 3x squared come from? I'm looking at that last term as cosh of u, where u is equal to x cubed, right? So when I differentiate hyperbolic cosine, I get hyperbolic sine evaluated at the inside function times the derivative of the inside function, which here is 3x squared. And there you go. That's it. Now, what if I said this was f of x, right? What if I said this was f of x, and then I asked you to calculate f prime prime of x? you said no. I also say no because I think it's pretty much time to start the weekend. But let's see here. So I think that's a pretty good selection of examples. If you look at the notes, there's more, right? I have more hideous, lengthy examples. I'm sure there's some pattern I've left off in our discussion today, but I think that gives you a pretty good starting batch of examples, and I hope that's enough for you guys to work your way through the homework. If there's any problem that doesn't make sense, don't hesitate to email me. I'll try to help you, all right? Oh, well, mission 5, 6, 7, the rest of it, differentiation's with us the rest of the semester. Like, this is always important going forward. Yeah, I meant 522. Yeah. Did I put that on the mission itself? I know I noticed that error somewhere and I corrected. No. I'm not going to be here Sunday to collect it. Don't worry. It's all good.